Hi students, next fourth unit. In this unit we are going to discuss about field effect transistor, right. In previous chapter we discussed about transistor, that is nothing but Bjt, bipolar junction transistor. So the field effect transistor belongs to transistor family, right. So FET has 3 terminals, right, just like a transistor. So these 3 terminals are source, gate, drain. The function of source is similar to emitter and gate function is similar to base terminal, and the drain terminal function is similar to collector, right. So the two applications, that means amplifier and switch of FET, are both same as Bjt, right. So the two main applications of FET are amplifier and switch, just like transistor, right. So what is the main difference between Bjt and FET, right. So we all know that transistor has 3 terminals, emitter, base, collector, right. In similar way FET has 3 terminals, source, gate, drain, right. So here the emitter emits the charge carriers towards the collector, and the base terminal which passes the charge carriers from emitter to collector, okay. So the collector collects the charge carriers, right. Okay, for suppose if you take CE configuration, right. So for CE configuration, input current is base current IB and output current is collector current IC. So that here the output current is collector current and input current is base current. Okay, what is the relation between IC and IB? IC equal to beta times of IB, right. So if IB increases, IC also increases. Beta is fixed value, so that IB increases, IC also increases. So that the output current IC is controlled by input current IB. Okay, so that the Bjt is generally called as current controlled device, okay, whereas FET, okay, so in FET the output current is drain current ID, right. So here the voltage between gate terminal and source, that is VGS, gate source voltage. Here this gate source voltage controls the drain current, means the output current is, that is drain current, the output current is controlled by input voltage, that is VGS, okay. So here the input voltage controls the output current, so that the FET is generally called as voltage control device, okay. So Bjt is current control device and FET is voltage control device, very important point. Next, second difference is, so Bjt nothing but transistor, B for bipolar, okay. So why it is called bipolar device? The current is, bi means 2, so 2 polarities, the current carried by both electrons and holes, okay. For suppose take NPN transistor. In NPN transistor, majority charge carriers are electrons, minority charge carriers are holes, means the current is carried by both electrons and holes, okay. In similar way, in PNP transistor, majority charge carriers are holes and minority charge carriers are electrons, so that the current is due to both holes and electrons, okay. So in transistor, the current carried by both electrons and holes, okay. So that it is called as bipolar device, okay. Next, FET is unipolar device. Uni means 1, okay. So the current due to only one single polarity charge carriers, okay. Maybe the current carried by either electrons or holes, okay. So depends on the type of FET, okay. So for suppose FET just like transistor. So transistors 2 types, N channel and NPN transistor and PNP transistor. In similar way, FETs are classified into 2 types, N channel and P channel, right. So here N channel, here channel is N type, so that charge carriers are electrons, so that in N channel Jfit, sorry, in N channel FET, the current carried by only electrons only, the current carried by only electrons, okay. In similar way, in P channel FET, the current carried by only holes, okay. So In FET, the current carried by only majority charge carriers. Here there is no minority charge carriers concept. Okay, the current is due to only majority charge carriers. So that FET is unipolar device, right? So that FET is more temperature stable, right? More temperature stable. Okay, why? Because for suppose take NPN transistor, the current is due to both majority charge carriers and minority charge carriers. Okay, so majority charge carriers are electrons for NPN type and minority charge carriers are holes, right? Okay, so here the majority charge carriers are due to the transistor action, and minority charge carriers are depends on temperature. Okay, not on applied voltages, it depends on temperature. Okay, means the current due to minority charge carriers depends on temperature. Okay, if temperature increases, okay, the current due to minority charge carriers also increases, so the output current also increases. Okay, so for transistor the output current is due to both majority and minority charge carriers. Okay, if temperature increases, minority charge carriers increases, so that the current due to minority charge carriers increases, so that output current also increases. So that output current will not be stable, okay, if temperature increases. Okay, so in FET the current is due to only majority charge carriers. So there is no current due to the minority charge carriers, so that here there is no charge carriers depends on temperature, so that FET is more temperature stable compared to BJT transistor, right? Next, fourth point, so FET has very high input impedance compared to transistor. So why? Because for suppose take transistor, so we told many times for normal proper operation for transistor, emitter base junction should be forward biased and collector base junction should be reverse biased, right? So here emitter base junction is input junction and collector base junction output junction, right? So here this input junction is in forward bias condition, right? So for forward bias condition, the PN diode offers very less resistance in forward bias condition. Okay, it is in the order of 2 to 5 ohms, so very less resistance. Okay, so that the transistor has very less input resistance or less input impedance. Okay, in similar way, for proper operation of FET, the gate must be in the gate source must be in reverse bias condition. Okay, just like transistor, for normal operation or proper operation of BJT, the base emitter junction should be in forward bias condition. In similar way, for proper operation of FET, the gate source should be in reverse bias condition. Okay, so that here input section should in reverse bias condition. So in reverse bias condition, the PN junction diode offers very high resistance, so that the FET has very high input impedance. Means in reverse bias condition, the PN junction diode offers very high high resistance. It is in the order of mega ohms. Okay, maybe 100 kilo ohms. Okay, 1 mega ohm. Okay, so in the order of mega ohms. Okay, so that FET has high input impedance compared to transistor. So transistor input impedance is in the order of 2 to 5 ohms, and FET input impedance is in the order of mega ohms. So that FET has high input impedance compared to BJT. Okay, so these are all the main differences between BJT and FET. Okay, so next one is classification of FETs. Okay, so FETs are mainly classified into two types, Jfit and MOSFET. So Jfit, J for junction field effect transistor, and second classification is MOSFET, metal oxide semiconductor field effect transistor. M for metal, O for oxide, S for semiconductor. Metal oxide semiconductor field effect transistor. Okay, and also it is also called as Jfit. I for insulated, G for gate. Insulated gate field effect transistor. Right? Again, junction field effect transistor, that is Jfit, again classified into two types, N channel Jfit, P channel Jfit. Right? So in similar way, MOSFET classified into two types, depletion type and enhancement type MOSFETs. Again depletion type MOSFET classified into two types, N channel, P channel, and enhancement type MOSFET again classified into two types, N channel enhancement type MOSFET and P channel enhancement type MOSFET. Okay, so this is the classification of FETs, right? So now in this chapter we are going to discuss all these things, right? Okay, so next, first one is Jfit, right? So first one, what is the structure of, basic structure of Jfit, right? So Jfit basically two types. Okay, one is N channel Jfit, second one is P channel Jfit. Okay, so what is the difference in structure for N channel and P channel Jfit, right? So first one is N channel Jfit. So here N type semiconductor bar is taken, okay, on which two heavily doped P type semiconductors are placed on each side of this semiconductor bar, right? So here these two P type materials are heavily doped compared to this N type semiconductor, right? So that it has three terminals, so drain, source, gate. Okay, so here source and drain both are N type, and here actually it has two gate terminals, so two P materials, so that two gate terminals, but here these two gate terminals are common together. Okay, so that it has single gate terminal. So finally it has three terminals, gate, drain and source. Okay, so drain and source terminals are N type and gate terminal is P type, right? So here the space between this drain and source is called as a channel, right? So here channel is N type material, this entire thing is N type material, so that here this channel is N type, so that it is called as N channel Jfit, right? So in similar way, this is P channel Jfit. So the construction of P channel Jfit is entirely same as N channel Jfit, right? So here drain and source are P type materials and gate is N type material, and the space between the drain and source is called as channel. So here channel is P type material, so that it is called as P channel Jfit, right? So in N channel Jfit the current is due to only electrons, in P channel Jfit the current is due to only holes, remaining all entirely same and operation is entirely same, right? Okay, so these two are the corresponding symbols. Okay, so this is the symbol for N channel Jfit and this is the symbol for P channel Jfit. Okay, so only difference is arrow. Okay, so arrow is here inward direction and here outward direction. So why? Because the current always flow from P to N. Okay, so P to N, so inside, so that the arrow is inside, and here for P channel type, so P to N, so P to N, so P to N outward, so that the arrow is outward direction. Okay, okay, so this is about introduction of FET. So this is about introduction of FET. Okay, so in next video we are going to discuss about clearly working of Jfit, so very important one. Okay, so thank you.